Okay, moving on. This is really the second problem in the notes. I don't know if your notes has that one written twice, but mine did. So this is the same kind of a setup. This is like the appropriate kind of thing to be dividing by. It's like x minus a number. In this case, it's x plus a number. You might think of this as x minus -3, x minus -3 be x plus 3. And the reason I might think about that is because it means I put the number that goes in the box is going to be -3. The other thing to notice here is that I am missing my dividend. Is that right? Dividend is missing a power. Like I have x cubed and then x squared and then no x to the first and then straight to the constant. So what that means is that I'm going to have to do a placeholder. Like I talked about. We talked about that a little bit in the long division. It's the same concept. Like if there's something missing, you want to write a placeholder. You really have to do it here or else things get really screwed up. But the coefficient of x cubed is 2. The coefficient of x squared is 7. The coefficient of x is 0. Like you could think of it there being a 0 there if you want to. And the coefficient of the constant term is -5. Like a side note, if you need to know this, like if there was no constant term, then you put a placeholder here, like you put a 0 here for the constant term. But each power of x from the largest one down to 0 has to be represented here somewhere. It's the x cubed, x squared, x, and like the constant, I don't know, okay, whatever, constant. So our process is 2 plus 0, or just bring down the 2, gives you 2 here. Multiply, add, multiply, add, multiply, and add. So bring down, multiply, add, multiply, add, multiply, add. This time my remainder is not 0. So now we're going to see how to write the remainders. So 2x squared plus, nope, cubed, all right. (2x cubed plus 7x squared minus 5 divided by x plus 3 equals, and then this is going to be no x's, 1x, 2x's, right? Like basically this, everything up here shifts to the left one for my new thing, but I think of this as being like no x's, 1x, 2x's. So it's 2x squared plus x minus 3. But what about what we end up doing with the remainder is you write the remainder as a fraction, as the numerator over whatever the divisor was. I know that that's confusing. I know this is the first time you've seen it, so I'm not trying to be like that's obviously what it is. I'm just telling you that that's how you write them. When you have a remainder, which is going to be just a number like this 4, that number goes on the top of a fraction in the numerator of a fraction whose denominator is whatever you divide it by. That's always how that works. I don't want to be too, like, you know that 7 divided by 2 is 3.5, right? Like this is the same thing. I didn't do that right. 7 divided by 2 is 3.5, or 3.5, right? And like if I do 2 goes into 7 3 times with a remainder of 1. So I do 3 plus, and then the remainder over the divisor, 3 plus 1 over 2. That's 3.5. That's 3.5. That's what I'm doing here. I rewrite whatever the remainder is over the thing I divided by. 7 over 2 equals 3 with a remainder of 1. So I do 3 plus 1 over 2. It's kind of the same idea. But anyways, whether or not you understand what I just did here, know that this is how you write the remainders. So things to remember if you want to use synthetic division, standard form. The polynomial you're dividing into has to have descending powers of x. It doesn't have to have all of them, but the ones that are there have to be descending. So if there are some that are missing, that's okay, but you can't have x squared to the left of x cubed. It's got to be descending powers of x, left to right. For polynomials, we call that standard form, but just so you know, that's what that means. Placeholders, for any missing power of x, you have to write a 0. In the write a 0 while in your synthetic division. X minus a, what that looks like, x minus 3, x plus 3, x minus 11, etc. And then how to multiply and add, which luckily we learned how to do long ago. So there's not going to be any like big complicated multiplications in these. It's just going to be pretty small numbers. So, all right, a couple more examples to do. I'll just go ahead and do them in this video. I'm not going to spend a ton of time explaining. I will say the reason these are here is because they have some kind of quirks. Like here, this is not in descending order, and this is x 4 plus x, but this is the same exact thing as x plus 4. So you might want to just rewrite this in descending powers of x. And then remember, this is really x plus 4, right? Doesn't really matter which order those things are in. So now I'm going to rewrite this. I didn't do this on the last one at the end, but you'll see. I'm going to do one more thing at the end of this one. -4 goes here because it's plus 4 over there. Now I bring 3 down, times -4 is -12. Add, I get -2. Multiply, I get 8. 13 plus 8 is -5. -5. Ooh, this should be a minus. It should be a -20. -4 times -5 is 20. Boom, remainder 0. That's always good. So this dividend, remember, no x's, 1 x, 2 x's. I end up saying something like, doesn't matter the order I write it in, but I'm going to write it in descending order because that's better. 3x cubed plus 10x squared minus 13x minus 20 divided by x plus 4 equals, and this is my quotient here, 3x squared minus 2x minus 5. And this is equivalent to saying 3x squared minus 2x minus 5 times x plus 4 equals 3x cubed plus 10x squared minus 13x minus 20. And the reason I want you to write it this way is because I want you to be aware that if you can factor this thing too, you're in really good shape. That's like the whole point of this. We're not going to do a ton of talking about the fundamental theorem of algebra or anything in this course, but that's the whole point of doing this, because next year in pre-cal, we're going to have to know how to do this. This can be factored, I think. I need minus 2x, I think minus 5 and plus 1. Minus 5 plus 3 is minus 2, yeah. So like being able to factor this big ugly thing into these 3 linear factors is really important. So like this is the synthetic division portion. This is one way to write the answer. This is another way to write the answer. And this is a third way to write the answer. And really these are all kind of the same. But the really important thing we're doing here is we're being able to rewrite something like this big thing with cubic in it is factored into 3 linear factors. That's gonna be very important to us later. Okay, so last one. Okay, this is good because the thing about this one that's different is that this is not quite the form that we like it to be in. So we're gonna rewrite this thing first. You gotta make it in descending order. 8x cubed minus 6x squared plus 7x minus 1 divided by, and now think about, there's a couple ways to think about this. Like whatever this, I want this to be like x minus a number. So to me, the best way to think about how to rewrite that is to factor the 2 out. So basically what I'm saying is like, this thing is the same as 2 times x minus 1/2. If I factor a 2 out of 2x, I get x. If I factor 2 out of 1, I get 1/2. Like if I divide this by 2, I get x. I divide that by 2, I get 1/2. So this is really 2 times x minus 1/2. And so the number I'm going to put in the box is going to be positive 1/2. And we're going to address the fact that there was a 2 here at the end of the problem. So we get 8x cubed minus 6x squared plus 7x minus 1. Now I bring this guy down and I get 8. And 8 times 1/2 is 4. I add these and I get negative 2. And 1/2 times negative 2 is negative 1. 7 minus 1 is 6. 1/2 times 6 is 3. Negative 1 plus 3 is 2. So here's the part where it gets a little hinky. We divided, what we ended up doing here when we put the 1/2 there is we divided this thing just by this part. We didn't divide it by the 2 yet. So at the end, you have to divide this thing by 2. So I'm going to do that. I'm going to say 4, negative 1, and 3. You don't actually have to divide the remainder by 2, I don't think, which is odd. But anytime the number here is not 1, anytime there's actually a coefficient on x, we have to do this. Like, you don't actually have to rewrite it like this if you can just see that this is going to be 1/2. But at the end, whatever this coefficient was, you have to divide all of these by that coefficient for it to work. So basically what we're saying is this: 8x cubed minus 6x squared plus 7x minus 1 divided by 2x minus 1 equals 4x squared minus x plus 3 plus 2 over 2x minus 1. So like these are the coefficients you want. Like you look at the difference between these 3 and these 3. The ones that I want are the 4x cubed and the minus x and the plus 3. And then the remainder just goes over 2x minus 1. You don't have to divide this one. Notice that I did not change the remainder. There's a lot of ways to think about that, but for me, the easiest way is to think that I'm actually dividing this thing by 2x minus 1 at the end, so I don't have to worry about the fact that I didn't do it here. But so this is like the last kind of wrinkle in synthetic division, is that if the number in front of x is now 1, you got to divide the coefficients by whatever that number was at the end. So the more practice you do with these, the better off you're going to be. There is practice for you guys ready to rock and roll. So get after that, and good luck.